huge shout out to all those doc writers out there. I built this demo today using those instructions. And if I can do it, I know you can too. I've already created a repo with a Docker file. Next, I'm going to create an actions YAML file. The metadata defines my important log stuff to capture, my time output parameter to pass inputs to the Docker container. GitHub will build an image from your Docker file and run the commands in a new container using this image. The cool thing is you can use any Docker image in any language for your actions. It doesn't matter if it's Go or whatever. In today's, I'm going to use a shell script and an input variable to print my important log stuff to file. And like I said, you know me, I love me some shell. Now you can do this in a couple of ways, whether you're doing it in your preferred IDE, or for today's demo, I'm just going to use the GUI. I'm going to navigate to my Actions tab. In my workflow, select New Workflow. It automatically loads some workflows declared to get you started. I'm using the one I've copied. Like I said, the lazy developer I am, I'm going to replace this with my action. So now we're going to go and we're going to start our commit. Now, if we go over to our Actions tab, we can see the workflow in progress. In my repository, I just click the Actions tab, and because I wrote the actions on push, we can watch the visualization under jobs and click the job to see the important stuff we're logging in the input stamp in the printed log. And we'll just wait for this to run. Hello, Mona. What up, Mona? And boom, it runs automatically.
Docker dev environments transform how your team collaborates. They make creating and sharing standardized development environments as simple as a Docker pull. They make it easy to review your colleagues' work without affecting your own work.
Dev environments are a new part of the Docker experience that makes it easier for you to get started with your hole in the loop. They allow you to share and collaborate more than just the code. We want to enable you to share your whole modern development environment, your whole setup from Docker with your team on any operating system. We'll be launching a limited beta of dev environments in the coming month. Dev environments are designed to be local first. They work with Docker Desktop and let you share that hole in the loop, that whole development context, all of your teammates in just one click.
This broadens trusted content by extending beyond Docker official images to give you more and more trusted building blocks that you can incorporate into your applications. We are pleased to share with you Docker Desktop on Apple Silicon.
What are your favorite CI tools? Like if you could create it from scratch?
Jenkins. I don't love the UI, but I love that it's been around so long. It has so much community support and there's so many plugins so that if you want to do something, you don't have to write the code. It's already been tested.
Yeah, I'm a huge fan of Jenkins. It's a tool that people really understand. For enterprise CI/CD, if you want, especially if you want to roll your own or own it yourself, Jenkins is the bellwether, and for very good reason.
Do you use Compose in your CI or not? Because
yes, I do. Shifting the CI left to your local development is trying to say, okay, how do we build an app? How do we build mocked dependencies of that app so that we can test our app? Trying to get them all to do all of this in Docker means you're running Docker build a lot, you're running Docker run a lot, you're running Docker RM. Trying to bridge all of those containers together into a single network can be challenging without Compose. I like using Compose to be able to really easily categorize and compartmentalize a lot of the things that are going to be done in CI, like building a Docker image. It's really portable that way. It doesn't work for every team. For example, if you're just a team that does one thing, then that might be a lot of overhead. In that case, you can get away with just Docker commands. It's not. If I build something that's similar to a make file or a rake file or what have you, then I'm probably going to want to use Docker Compose.
Docker Compose v2, which is now built into the Docker command line. So now we're shifting from the Python built Compose, which was a separate package. One of the challenges was getting it into your CI solution. Because if you don't have pip, and you got to download the binary, and the binary wasn't available for every platform. Now that it's in Golang and it's plugged right into the Docker command line, it hopefully will be easier to distribute, easier to use, and you won't have to necessarily have dependencies inside of where you're running it.
Applications are different. There's no single approach to security to fit everyone's environment. A risk might be that somebody manages to steal your data, and the effect of that, the risk is much higher if you're a bank or you're holding health data. What's the path to that risk occurring? So it could be a malicious actor trying to steal that data, or it could be just things that you could inadvertently get wrong that would end up revealing that data to the world.
Security is another cross-cutting concerns that developers need to handle, along with performance and accessibility and countless other things. How do we make it usable and actionable for them to actually fix security issues? For application developers, they're probably not as close to kind of like the bare metal of a container from like the Cgroups and the namespaces levels, but they do care about, they choose maybe the Docker, base image. So choosing it correctly, building it, correctly is a good thing to practice. you can take it a bit more. For example, the applications that I'm building, and like maybe I'm scanning, all of my, work, my project and my dependencies and things like that locally. But what happens on production, right? What's happening, there might be I'm calling it like this dependency parity drift, right? Where it's not the same. What you are building and scanning and maybe fixing at the repository level is not actually what's right now deployed on like a running container, somewhere else being orchestrated. And you might be fixing what you have right now, but something else running in production is still actually maybe vulnerable. When I talk a lot about container security and the best practices of building images in a secure way, for applications in Node or Python or something else, a lot of the time people still focus on the vulnerabilities maybe present in a container image, which is okay. But I've seen that what they're missing on is the runtime itself, right? The runtime itself is vulnerable, and people do not spend enough time thinking about that. They're thinking about the versions of the Node runtime from supporting language features. I try to take them towards what impacts the app from those kind of layers, which is also the quick wins that they could understand. You want to have as many security layers, that principle as much as possible. So that's kind of like what I think is resonating and very helpful to mitigate those kind of security vulnerabilities on the app level.
What are containers? What are Cgroups and namespaces?
Containers are just Linux processes. There isn't really a concept in the Linux kernel of a container. You're creating a process, but you're restricting what that process can see and do. For example, you might say, I'm going to give this process ID namespace. And that means it can only see the other processes and the process IDs inside that namespace and not any of the other ones running on the host. Cgroups is a similar way of restricting a process. For Cgroups, it's about what resources can I use. So you might limit the amount of memory. The host can see everything that's happening inside that container. The namespace is kind of, and the Cgroups are only sort of from the process's point of view, from the container's point of view. From the host perspective, they just look like normal processes.
DevSecOps.
DevSecOps is just putting acceptance criteria onto security tickets. You do that one thing and everything else follows, because you need the culture, you need the people, you need somebody embedded in the team.
GitOps, if you haven't heard about it, is essentially using versioning systems like Git, like we've all been getting used to as developers, to track your infrastructure changes, not just your code changes, and then automate that with a bunch of tooling so that the robots take over. You have Git as a central source of truth, Git log as a central source of history, and then there's a bunch of magic little bits in the middle, and then supposedly everything's wonderful and it's all automatic. I can point people to a repo. Hopefully, if they look at the log, a simplistic tracking of what might have changed in that part of the world or in the environment.
I think my favorite part about GitOps is reproducibility. The ability to just test something and get it up and running and then just tear it down.
Git, everyone knows Git. Git's the source of truth. There's a load of robust tooling. This just makes a sense. Like if everything dies, we can just apply the Git again, and that will be great.
What I like about it is the potential to apply it to moving security to the left, getting closer to a more stable infrastructure as code with respect to the whole entire environment.
How do we handle security?
The tooling that you have for your Git repo, authentication, authorization, and permissions that you apply to the Git repo using a Git server like GitHub or GitLab is going to be how security is handled with respect to changes in your GitOps configuration repository. Completely specific to your implementation of that, or one's implementation of how they're handling the Git repositories that the GitOps tooling is looking at to reconcile changes.
So we're going to be talking about container-first development.
For me, container-first development is really about considering containers as sort of a first-class citizen in terms of your development toolkit, right? So if I don't have to have 6 different browser tabs open with an API server running in one tab and a web server running in another tab and a database running in another tab, I can just encapsulate those and use them as an automation thing.
There are obvious benefits when it comes to the developer experience of containers. Consistency, we have standardized tools, dependencies for the dev side of things, but it also makes your dev environment more similar to all the pipeline that is somehow happening to the right. So CI/CD all the way to production. It is security, right? Which also somehow comes with standardization. But vulnerability scanning, tools like Sneak are doing a great job there. For us at Gitpod, reasons why we created Gitpod was literally creating this peace of mind for devs. You do not need to take care anymore about all the hustle around setups and things that you need to install based on some outdated README on 3 operating systems in your company. Everybody has something different, leading to these works on my machine situation that really slow professional software developers.
When it's a single application, if you have just one component, maybe it's easier for you to kind of run it locally, have a very simple testing environment that's sufficient. However, I think it's more important when we think into the bigger picture, when we have an architecture that has myriads of microservices at the basis, when it's something that you have to expose, for example, an API, or you have to consume an API. These are kind of things where you might need to think about a lightweight setup within the containers on your local environment to make sure that you have at least a similar environment or configuration to make sure that you test some of the expected behavior.
There's more people doing more work all the time, especially post microservice boom created all sorts of new prompts for new tooling. And
deployments happen in a certain way depending on my needs. Depending on what I want to deploy, I have to do more or I have to do less. And then this is a new way, a new strategy of deploying something. There's more something like a more standardized strategy that's widely adopted versus a strategy that's experimented with.
It's not really that sysadmin role is now becoming less. It's more about us constantly doing different things. Some things become easy, some things become much faster. Same role needs to jump on a layer higher or lower, depending on how you look at it, and do some different things. If you define sysadmin as a person who SSHs into a server, then that role doesn't exist anymore. If you define a sysadmin as a person who manages the whole system, then it very much exists.
I'm just laughing at this comment. A great comment from Duck that says, if you don't have a sysadmin, then you're the sysadmin. You know, the cloud removed the power, it removed the cabling and the care about racking servers, right? It removed our concerns from that, and we can just use these resources. But it hasn't really removed the OS, right?
Docker and containers represented massive improvement in UX around a lot of those lower level primitives. That there's a lot of value in remembering not to dismiss lower layers. Like you almost always need to dive in and understand those lower layers at some point. So you will have to figure out a problem.
Every major revolution in tech has been about changing the speed at which a person can do things with tech. We have better tooling, we have better systems, and Docker did that, Kubernetes is doing that, and the next thing is going to do that too. So
I hear often those statements like Kubernetes is more complicated than Next. Kubernetes is not more complicated than other things. It is doing more things than other things. If you would compare the same feature set of whatever you want to compare Kubernetes with, then Kubernetes is that easy, right? Remove service mesh, remove service discovery, remove fault tolerance, and all the things that you didn't have before, and then suddenly it's easy. Every next generation of something is always more complicated, not necessarily because it is poorly designed, but because it is doing things that mortals couldn't do before.
I also had some really wonderful women mentors in the community that I was in. There were 3 women who were like leaders in the community, and I was like the only other woman there of everybody. And they really took me under their wings, and I think I got a kind of a head start, and never really felt like I shouldn't be where I was, and also being independent. I think for so many years, also I wasn't in kind of a toxic environment because I had a lot of street cred for my clients and everything.
Changed my major to computer science. I was also very fortunate when I started getting employed. I got an internship at a company. The CEO was a woman at the time. There were very small teams. It was a small company to begin with, but I think every team I've been on, there was at least one other woman. Also had good experience with mentors, and it was never really strange. Every now and then I'll get the offhanded comment like, you don't look like a developer, something like that. But, those things are just funny. You just brush them off.
And what I'm really striving for is a landscape where people don't have to say, oh, first you prove yourself and then you're accepted, and just jump directly to that thing where you show up and you don't have to waste your energy. It's such a waste, right? Like, use your energy to do interesting stuff, solve interesting problems, make interesting projects, and don't spend on something boring like trying to convince somebody that you deserve something that is your right by nature anyway.
I had a lot of great support. My manager at the time, slowly letting me work my way up towards that, getting involved, shadowing that. But overall, I've definitely had those experiences of being a woman in tech. And
I'm excited to be here with you to talk about write once, deploy everywhere. This is a getting back to the basics talk, to talk about some of the fundamentals and some of the underlying principles. Some of these standards, actually most of these, are defined by what's called the Open Container Initiative, or OCI. And a lot of this work was spun out of a lot of the early work of Docker, And Docker really tried to make open standards. So OCI defines an image specification, a runtime specification, as of just a couple weeks ago, a distribution specification as well for the API endpoints for a registry, etc. While there are many OCI compliant runtimes, the one that gets probably the most use is called Containerd. And again, we're not going to spend a lot of time talking at this low level, but it's important to understand that there are standards at play here. And Containerd is a CNCF graduated project, which is pretty awesome. So who's using Containerd? Pretty much anybody that you're going to be interacting with. If you haven't heard of the 12-factor app, I would highly encourage you to check it out. It's at 12factor.net, and it has 12 different principles on how to build cloud-native applications so that your application can be portable. Its configuration is composed of two main ideas here. You'll see this get represented a lot, especially the container orchestration system. So again, config encompasses anything that might vary. And a lot of times what you hear is config, and then you'll hear secrets. And a lot of times people are like, what's the difference? Think of secrets as anything that's sensitive. So database credentials, API keys, etc. While config is, again, everything that will vary. Yes, your API keys and your database credentials may certainly rotate, but they're a little more sensitive, and so they need to be handled maybe with a little bit more care. So one of the things that the 12-factor app talks about is environment variables. It says the 12-factor app stores config in environment variables, often shortened to env vars or just env. So when should you use and not use environment variables? I know there's a lot of debate, but I'm a pretty big stickler about this. Environment variables are completely fine for changing options or labels or non-secret data. Talk about how to actually get files into containers. There are several mechanisms. For local development, just use file mounts. And you can do a Docker run with a -v for a volume and mount in a volume, or Docker Compose as well. When running with orchestration, so whether it's Kubernetes or Swarm or ECS or whatever, you can use config or secrets. And they will make it easy to provide configuration in the orchestration, whether secret or config. So secrets and orchestration, secrets are typically stored within the cluster, and they're stored encrypted at rest, blah, 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 blah. And then they're provided only to the authorized container. To an app, it's simply just a file that somehow magically appeared. And pretty much every orchestration framework, that file will be in a tempfs volume, which means it sits only in memory and it will never actually touch the file system. So let's look at an example app. I'm actually going to be leveraging the same front-end code of the Docker tutorial getting started, but I'm swapping out the backend with a Spring Boot app. I've got an image here. I'm going to mount the config properties into the container app config application properties, and it will use that. With Swarm, maybe it looks a little different because now I've got a little bit more orchestration, and the container may be running on one of N nodes in my cluster. And so I don't know exactly where it's going to run, and I can't just mount the volume. Okay, so the way that I can do that is I can enroll a secret. So I'm going to enroll a secret named app properties. The file is going to be this config properties, and then my app container will reference and say I want to use that secret, but I'm going to put it at this place. So app config application properties. And so again, when my app starts up, it's just going to read that file. It's going to configure itself, and it's going to be great. And I'm going to switch over to Chrome here, where I've got the play with Docker set up, and I've got a 5-node cluster here, 3 managers, 2 workers, and I've got the Docker stack, config properties, and config JSON. And again, I'll talk about how I'm configuring the front end in just a minute. But if I do a Docker stack deploy, all right, so it looks like we're about good to go there. And if I open up the front end, okay, it starts up, and I can say I want to, what are some of my to-do items? Finish recording my talk, and I can save it, and it goes. Now, so if I look at the config here, now for this one, I've changed the Mongo connection to be this, and my core's origins, I had to populate it with the domain that this Play with Docker instance is using. And so again, I'm able to configure where my front end is going to be. And if I look at the config.json that the front end is using, this is how I'm configuring where the back end is located. So let me talk about configuring single page apps real quick. What I see too often are things like this, where in maybe a React code, it's using process.env.api host. And that means that this will resolve at build time and get swapped in. And so then you're always stuck with whatever API host was at build time, and you can't change that later on. Okay. And so one of the ways that you can solve this is now what I did, and this is just a React example, when my app starts up, I fetch a config JSON that has all the configuration that can change. So in this case, where is my API host? So I fetch that, and then I pass that config to my React app, which sets it in a config context. I say, here's the value. And then anywhere in my app, I can use that context to say, hey, give me the API host. So now when I fetch API host, it's really giving me this value. So localhost 8080/item. So configuring with Swarm, all I have to do is swap out the sources, and that's pretty much it. The config JSON. And with Kubernetes, it's much the same way. Containers have standards, just like intermodal containers that allow us to configure how we connect to them and make them portable and reconfigure them. Configuration is one of these mechanisms, and we can use environment variables and files, leverage the files, the orchestration system that you're deploying in, as well as whatever you're developing in. Use what makes the most sense. Write once, configure to deploy anywhere.
Docker communities is what makes this strong, makes it work. And through trials like COVID and other challenges of last year, let's all respect that. Let's cherish that. Let's protect that. And let's look forward in the next 12 months. Have a great 12 months and figure out what Dockercon 2022 looks like. And just want to say thank you to community. Thank you to the sponsors. Thank you to the Docker team. Went above and beyond to make this happen. Thank you to the Docker captains and the community behind the scenes. Phenomenal event. I just want to thank everyone so much.
That'll wrap it up. Thanks, everybody. We'll see you.
Thank you.
We'll see you soon.